Hello, Richie here. I'm just going to explain my contribution to the project and what I learned. So my contributions to the project was basically the design. Um, my initial design was basically, you know, having a user tug on the tube. So one tug would either to contract or retract, and the two tugs or whatever, two, three tugs would be, you know, the opposite, and the motor would just read off of what the user would tug. But I realized that's not kind of a good idea just because if anything becomes faulty, the wire's still on the floor and she'd still trip or anything can happen. Um, so I was kind of thinking maybe we should shoot it up the on the ceiling. So I thought about having it on the ceiling, and it kind of work out just because we'd have the oxygen tank on the floor up to the cable reel, and then hits the tension arm, which is the potentiometer, and then the pulley, and then to the where the tube would come in, where the user would have a a belt attached to her, and so it wouldn't be just right to the masses in case the tension's too tight. It would just pull the mass right off. So we actually have it on. We would actually put it on the belt, which would if anything happened, it would just pull off the belt rather than her face. So that's kind of my point. I kind of just had the overview and had the overall idea how it would work and how everything would just run through. What I learned was turning something so simple would be and adding a sensor and a motor would be so helpful for someone in need. Just making something smart would be something so useful for somebody like this. That makes me really happy, just helping out somebody like that. Um, I also learned was everybody has their own skill set in the group. We had Vincent was really good at programming. We had Mohammed who can put the electrical, everything, the circuit together, and me, seeing how the big picture, how everything went, kind of going through the program and seeing, okay, I understand where you're going here, and maybe you should add this, maybe you should add that. And with Mohammed, say, oh, this is probably in the wrong spot, or maybe just little things like that. And also, I learned that having a good time is, also okay. We all had a couple laughs, but we still got stuff done. So it really, really was an awesome
Hi, this is Vincent, and this is my contribution to the ME106 project, the oxygen tube tender. I contributed to the program and assembling some of the hardware on this project. The labs had me relatively well prepared for the program, and it pretty much worked from the get-go. Some minor adjustments need to be made after running the rough draft of the program, but it was simply adjusting the parameters to have the project operate to our specifications. What I learned from this project was mainly improvising with whatever materials at hand. Like, for instance, we didn't have a 12-volt power source that could be run at all times. Instead, we had to use a small 9-volt battery that we had to worry about draining. Also, some of the components on the mechanical components on the project needed to be made by hand, like the reel on the stepper motor, the tension arm on the potentiometer. A lot of these, the first instances of our creations, the parts broke, so we had to redesign the components. And that is what I learned and what I contributed to the project.
Hello everyone, my name is Mohammed Nair, and I'm making this project for my ME106 Introduction to Mechatronics class taught by Dr. Furman. Our project was to make this oxygen tubing minder for the elderly lady. So my part was to make the electronic side of this project, so I'm going to explain what I learned about it in this project. So we used a stepper motor, a solderless breadboard, Arduino Uno, the driver board for the stepper motor, and external power supply. And we used a potentiometer, which I'm going to show you from the front side. So we used a solderless breadboard. We learned how to access the rails running through it, how to power the solderless breadboard, and use it to jump it through using the jumping wires. We used a stepping motor to make the rotations for our pulley. So we connected the stepping motor to our driver board into the required connections. The driver board has two options to connect two motors. So we have only one motor, so we only used one of it. We powered the driver board with the external power supply and the Arduino. So we're providing it a 9-volt from the battery and then the 5-volt from the Arduino. And we used the required pins as instructed in the lab manual. we get a hand-on experience how to connect the pins from Arduino and the input and the output from the Arduino to the driver board, and how to power it all together. Now I'm going to show you the front side of my project. That was the stepping motor. So this is the overall total assembly of this project. As you can see, we have used a nail here to stop the potentiometer arm. If I remove this, you can see the potentiometer in here that is used to sense the temperature in this cable. So this was my part of making the electronic circuit, and the rest is explained by my other group members. Thank you for watching, and this project was for ME106. Thank you.